Next topic is change of variable or substitution in triple integration. So there are two types to change the variables in triple integration. So similar to double integration, the formula for changing the variable for in triple integration is what? Suppose this is triple integration over D and the original variable are x, y, z. Then replace x, y, z by new variables u, v, w. That is find the value by replacing x, y, z by in terms of u, v, w. Sorry, in terms of new variable, and find the value of this of x, y, z, this function. Suppose this function converted to capital F function of u, v, z. That is, we substitute that. Suppose x is the function of u, v, w, y is the function of u, v, w, z is the function of u, v, w. That is, this is the substitution. Suppose that is, substitute x as the function of u, v, w. That is its value, y value, and z value in this way. This function converted to some another function. Suppose this is capital F u, v, w, and then dx, dy, dz is replaced by mod j du, dv, w. What is mod j or j is dava x, y, z, dava u, v, w. Okay, so this is the formula for change of variable in triple integration, similar to double integration. That is, in double integration, fxy changes to f of uv, and the dx, dy change to mod j du, dv. In this, there is three variables. Then there are two types. That is, first is change to cylindrical polar coordinates, and the second is the change to spherical polar coordinates. So there are two types in the triple integration. And what are the cylindrical polar coordinates? X is equal to rho cos theta, y is equal to rho sin theta, z is equal to z. Or x is equal to r cos theta, y is r sin theta, and z is equal to z. Right here, rho or r notation. Okay, so these are called cylindrical polar coordinates. And if we take these cylindrical polar coordinates, then mod that is z, Jacobian is what? Dava x, y, z, dava rho theta z or r theta z. And by using the definition of Jacobian, we have dava z by dava rho, dava x by dava rho, dava x by dava theta, dava x by dava z as the first row. The second row is dava y by dava rho, dava y by dava theta, dava y by dava z, and the third row is dava z by dava rho, dava z by dava theta, dava z by dava z. Either write notation rho or r. So we are familiar for the notation r. We can also use the notation r. And then dava x by dava p is what? That is the notation, that is the derivative of this x with respect to rho is cos theta. With respect to theta of this x is rho is constant, cos theta derivative is minus sin theta, so minus rho sin theta. In this way, we have the answer rho or r. This is the job. And then dx, dy, dz in the triple integration replaced by mod j, dr, d theta, dz. And what is mod j? Mod j is rho or r, dr, d theta, dz. And so these are the change in the triple integration. So change to spherical polar coordinates. These are the cylindrical. These are the spherical polar coordinates. These are the cylindrical polar coordinates, and these are the spherical polar coordinate. That is, x is rho or r. Right notation rho or r. Rho sin phi cos theta. Y is equal to rho sin phi sin theta, and the sin phi is fixed. That is sin phi, rho sin phi. Here is rho sin phi. Cos theta, here is sin theta. And z is what? Rho cos phi. So these are the spherical polar coordinates. And obviously theta, phi runs from 0 to pi. Theta runs from 0 to 2 pi. And rho from 0 to infinity. 0 to infinity. Okay. So its Jacobian is what? Dava x, y, z, dava rho phi theta is what? Dava x by dava rho, dava x by dava phi, dava x by dava theta, dava y by dava rho, dava y by dava phi, dava y by dava theta, dava z by dava rho, dava z by dava phi, dava z by dava theta is the third row. And now the derivative of x with respect to rho is sin phi cos theta. Then with respect to phi, derivative is sin phi, derivative is cos phi. So rho cos phi cos theta. And then dava x by dava theta is minus rho sin phi sin theta. Okay. Similarly, the derivative of this y with respect to rho phi and theta and the derivative of z with respect to rho, phi, and rho, phi, and theta. With respect to theta, derivative is 0. So we have, after finding this determinant, we have the answer rho square or r square sine phi. And so if we replace in triple coordinate, in the triple integration, use spherical coordinates, then dx dy dz is replaced by mod z d rho or dr d phi d theta. That is r square. What is mod j? Mod j is r square or rho square sine phi d rho or dr d phi d theta. So in order to change the variables in triple integration, either use cylindrical polar coordinates or spherical polar coordinates. So the examples on these. So find a spherical coordinate equation for the sphere. So we have to convert this equation of sphere in a spherical coordinate. That is, use x as r sine phi cos theta. Either use rho notation or r notation. I think r notation is familiar to us. So use r where this is rho is used. So x is r sine phi cos theta. That is, this x is r sine phi cos theta. Y is r sine phi sin theta, and z is r cos phi. Okay, and then x square plus y square plus z minus 1 bracket square is equal to 1 converted to, that is, substitute x as this value, y is this, and z is this, and simplify. We have the answer. So here we take, if we take r sine square phi as common, then we have in bracket as cos square theta plus sine square theta is 1, and therefore r square sine square phi plus cos square. Then next step, take r square as common. We have sine square phi plus cos square sine square phi. Here is cos square phi. This is after expansion. And then we have r square 2r. Either use r or rho notations. Here is confusion that sometimes used r as well as rho. Here is right r. So 2r square as 2r cos phi, 2r cos phi, and then take cancel one r from left side and right side. We have r is equal to 2 cos phi. So r is equal to 2 cos phi is the polar equation of sphere. This is the spherical coordinate. Polar equation is called polar equation. Okay, so spherical polar coordinates, polar coordinates used in the, and this equation converted to this. So the question for 2 marks, that find spherical coordinate equation or polar coordinate equation. It's called polar equation. So both are the polar coordinates, but this is spherical polar coordinates, and these are cylindrical polar coordinates. So next example, find spherical coordinate equation of the cone. That is, substitute x, y, z as these values. X as this value, spherical polar coordinates, y as this value, and z as this value. So we have this answer: r cos phi is equal to x is r square sine square phi cos square theta, r square sine square phi sine square theta. Then take r square sine square phi as common. Cos square theta plus sine square theta is 1, and then its root is this r sine phi. Take cancel r from both sides, and then sine phi by cos phi is 1. That is, tan phi is equal to 1, and so phi is equal to pi by 4. Theta, tan phi is 1, means phi is tan inverse 1, that is pi by 4. So phi is equal to pi by 4 is the equation of cone in spherical polar coordinates. So the example of triple integration using the spherical polar coordinates and cylindrical polar coordinates. So the first example, evaluate triple integration e raised to x square plus y square plus z square. So these are in the scalar polar coordinates. If there is x square plus y square, then use polar coordinate in 2 variable function or in double integration. Like that, if there is term x square plus y square plus z square, then use spherical polar coordinates. So d is what? X square plus y, x, y, z, such that x square plus y square plus z square is less than or equal to 1. So this is given. And then d is, here d is spherical region. D is a spherical region because x square plus y square plus z square is equal to 1 is the equation of sphere with center 0, 0. And so use the spherical polar coordinates, and that is use x as r sin phi cos theta, y as r sin phi cos theta sin theta, and z as r cos phi. If you find x square plus y square plus z square, x square plus y square plus z square, then it is what? Actually, this is x square plus y square plus z square. X square plus y square plus value of x square plus y square plus z square. X square plus y square plus z square here is equal to what? If we solve x square plus y square plus z square, then it is r square or rho square, r square or rho square, right? A rho or notation r square. So x square plus y square plus z square is r square, and raised to 3 by 2, and integration from 0 to 1, 0 to 2 pi, that is the limits. Remember these limits. Phi runs from 0 to pi, theta runs from 0 to 2 pi, and r or rho runs from 0 to infinity. So here is 1 is the so r runs from 0 to 1 because radius is 1. So r runs from 0 to 1, theta runs from 0 to 2 pi, and phi runs from 0 to pi. So these variables, these are the limits, and this dv means dx dy dz, and dx dy dz is replaced by what? Dx dy dz. Here is the dx dy dz in spherical coordinate. Dx dy dz is replaced by r square sin phi dr d phi d theta, or d rho d phi d theta, r square sin phi, that is here r square sin phi rho square sin phi d rho d theta d phi, or r square sin phi dr d theta d phi. Use notation r. Then it's simplification. So e raised to r square raised to 3 by 2, rho square raised to 3 by 2 is rho cube, to get cancelled, rho cube, e raised to rho cube. It is not p, rho cube, e raised to rho cube, and this is rho square sin phi d rho. Then first find the integration with respect to rho or r. R runs from 0 to 1. So the notation, the r square, the integration is r cube by 3, or rho cube by 3. Then upper limit, lower limit, that is 1 by 3 minus 0, that is we have the 1 by 3. And then integrate with respect to theta. So there is no term of theta, so its integration is into 1. And upper limit is 2 pi minus 0, that is 2 pi is the upper limit. And then integrate with respect to phi, sin phi is cos phi. Then upper limit, lower limit, cos pi minus cos 0. Cos pi is minus 1, and cos 0 minus 2. And then 4 we have this. So while integrating with respect to r, this is e raised to r cube into, so that is substitute r cube as 1, r cube as t, and then with derivative 3r square is like that. So change of variable, by substituting the variable we have this answer, 4 by 3 pi e minus 1. So using spherical coordinate, find the volume of the solid that lies above the cone z is equal to root x square plus y square, and below the sphere is x square plus y square plus z square is equal to z. So here the equation of sphere is x square plus y square plus z square is equal to z, that is x square plus y square plus z minus 1/2 bracket square is equal to 1/2 square. So this is in the standard form. So center is what? This is x minus 0 bracket square, this is y minus 0 bracket square. So 0 0 1/2 is its center, 0 0 1/2 is its center of the sphere, this sphere and this sphere. And so this is the diagram, and the radius of the sphere is 1. Radius of the sphere is 1. Okay, and volume of the solid lies above the cone z is equal to root x square plus y square. So this is the cone z is equal to root x square plus y square below the sphere. x square plus y square plus z square is equal to volume of the solid that lies above the cone and below the sphere, above the cone, that is this. Okay, and use the spherical polar coordinates, that is we convert the equation of sphere in spherical polar coordinates, that is the equation of sphere, that is substitute x as uh, r sine phi cos theta, like that, and that y is this polar coordinates, and convert the equation to, I think, like this, calculate this like this. We have this, that is x is r sine phi cos theta, y is r sine phi sin theta, and z is r sine phi, r or rho notation, and then find the polar equation of that sphere. So we have the polar equation of sphere, of this sphere, x square plus y square plus z square is equal to z. We have, this is the polar equation, rho is equal to, or r is equal to cos phi is the polar equation. Okay, and the equation of cone can be written in the form, again, the polar equation of cone, that is this is the cone equation of cone, z is equal to root x square plus y square, that converted to phi is equal to pi by 4, and the solid in sphere coordinate is, so d is rho or r theta phi, theta runs from 0 to 2 pi, phi runs from 0 to pi by 4, because phi is pi by 4, and rho runs from 0 to cos phi, rho, value of rho is cos phi, so 0 to cos phi, and therefore value of d is equal to v is equal to double integration over d dv, that is convert the one variable to, that is z, in terms of z, value of z. So z is root x square plus y square, so z is root x square plus y square, and that's why we have the rho square sin phi, rho square sin phi, that is the dv means dx dy dz, and dx dy dz is replaced by dx dy dz in polar coordinate, dx dy dz is replaced by here the dx dy dz is replaced by r square sin phi d rho d phi d theta. Okay, so here the polar two variable function, so it is replaced by r square sin phi dr d phi d theta, triple integration, right? Triple integration, not it is double integration, triple integration over t, and then because integration of one, triple integration, right here, triple integration 1 dv, and therefore dv means dx dy dz replaced by this r square or rho square sin phi dr d phi d theta, and theta rho r runs from 0 to cos phi, theta runs phi runs from 0 to pi by 4, and theta runs from 0 to 2 pi, and then first find the integration with respect to r, we have this, and then upper limit lower limit value, then find the integration with respect to phi, and then find integration with respect to theta, we have this answer pi by 8. So this is another problem on the cylindrical polar coordinate. Using cylindrical polar coordinate, we have to solve this triple integration, that is x is r cos theta, y is r sin theta, and z is equal to z, and therefore the region is x plus y plus z, x y z, such that x square plus y square is less than or equal to 1, and z runs from 2 to 3. Transform to new notation, rho theta phi or r theta z, and what is the limit of r? 0 to 1. R runs from 0 to 1, because this x square plus y square is equal to 1 is the circle with having radius r, radius 1, so 0 to 1. Theta runs from 0 to 2 pi, because we have to cover the whole circle, and z runs from 2 to 3, and therefore, and dx dy dz is replaced by mod z dr d theta dz, and what is mod j? Mod j is r. Sometimes here use r notation, sometimes use rho notation, so use throughout r notation, so r dr d theta d phi, and then triple integration over this given triple integration, this is equal to integration, triple integration 0 to 1 is limit on r, 0 to 2 pi limit on phi, uh, theta, and 2 to 3 is limit on z. That is the order is what r, then theta, and then z. Okay, so and z as it is x square plus y square is r square, and this dx dy dz is replaced by r dr d theta. Either use notation r or theta. Then this r square and r is r cube, and its integration is r raised to 4 by 4 from 0 to 1. Then value at the upper limit, value at the lower limit, we have 1 by 4. Then integration with respect to theta is z is constant 1 theta from 0 to 2 pi. Then value at the upper limit is 2 pi, value at the lower limit is 0, and then lastly 0 z integration z square by 2 from 2 to 3. We have the answer 5 pi by 4. And the volume of the sphere of radius a using the spherical polar coordinate. These are the spherical polar coordinates. X is equal to r sine theta, sine phi cos theta, and this. And then volume of the sphere of radius a. This is the equation of sphere of radius a. X square plus y square plus z square is less than or equal to a square. Is equal to a square means sphere, and its volume is this, less than or equal to a square. That is the whole portion lies in the sphere. And this converted to transform to v dash r, new notation phi theta. R runs from 0 to a radius, then phi runs from 0 to pi, and theta runs from 0 to 2 pi. These are the lower limit, upper limit of phi and theta. Only we have to decide the limit of r in the spherical polar coordinates. So then dx dy dz is mod j, dr d phi d theta. It is mod j is r square sin phi dr d phi d theta. And then region required volume is equal to triple integration over r dx dy dz. Actually, this is the volume of the sphere, but now we have to find it's using spherical polar coordinates. That's why the limit is 0 to a, 0 to pi, 0 to 2 pi of r, phi and theta. R square dx dy dz is replaced by r square sin phi dr d phi d theta. And then first integrate with respect to r. So we have this r cube by 3, r cube by 3, r runs from 0 to a. So we have this is the value. Then integrate with respect to phi, sin phi integration is minus cos phi from 0 to pi. Then value at the upper limit minus value at the lower limit. Cos pi is a minus 1, and minus cos 0 is minus 1. Minus 1 minus 1 become minus 2. So here is 2 by 3 a cube, and then its integration is theta, because 2 a cube is constant with respect to theta. Integration is theta 0 to 2 pi. Value at the upper limit is 2 pi, value at the lower limit is 0. And so we have 4 by 3 pi a cube. This is the volume of the sphere using spherical polar coordinates. Okay. So evaluate this integration. Again, this is the sphere with radius 1 over this x square plus y square plus z square. If we take x square plus y square z square as a 1, then we have a volume of the sphere of radius 1. So that if you take a as 1, so here we have to solve this integration over this integrand, that is x square plus y square. So use spherical polar coordinate, that is x is r sin phi cos theta, y is r sin phi sin theta, and z as r cos phi. Then r runs from 0 to 1 because radius is now 1. Theta phi runs from 0 to pi, and theta runs from 0 to 2 pi. So limit on phi and theta in spherical polar coordinates are fixed, that is 0 to pi and 0 to 2 pi. Just decide the limit of r, and then dx dy dz is replaced by r square sin phi dr d phi d theta, because in double integration and triple integration dx dy dz is replaced by mod j dr d theta d phi. Okay, so we have this answer, that is x square plus y square plus z square is r square, and this dx dy dz is replaced by r square sin phi dr d phi d theta. And then r runs from 0 to 1, phi runs from 0 to pi, and theta runs from 0 to pi. Then integrate with respect to first r raised to 4, its integration r raised to 5 by 5 from 0 to 1. Value at the upper limit, value at the lower limit. Then with respect to theta integration, sin theta, integration of sin theta is minus cos theta 0 to pi, and this is minus 2 answer, because minus cos pi minus cos 0 minus 1 become minus 2. So we have the answer from 0 to pi, and then value at the upper limit, value at the lower limit. Cos 0 is actually cos pi is -1. So minus minus become plus, plus 2 answer. So 2 by 5 then, pi, d pi integration is pi, 0 to 2 pi, and so 4 pi by 5. So these are the problems of triple integration, change of variable in triple integration. We can change the variable in the triple integration in two ways. That is, either use spherical polar coordinates or use cylindrical polar coordinates. That depend on the example. So remaining example we will see the next lecture.